day everyone. Good morning ma'am. Today, I will present about the calibrating of the needle or pointer of an analog multitester. So before we start, let's know as about the part of the multitester or multimeter. So first, we have a scale. So this part is this is how you read the value of being measured. So we can read the different variations such as the voltage and current and the resistance sa taas. And the next one is the needle or the pointer. So this needle is shaped rod that moves over the scale of a meter. So the needle is point the value of indicate the value being measured by the multitester. So next one is our adjustment screw, and this part is also known as the dial or infinity knob, allows you to adjust the pointer to the zero position of the scale. So next one is our 0 ohm adjustment knob. So the 0 ohm adjustment knob is used to calibrate our multitester when you want to measure the resistance of an object. Yeah. Next is our range. So in our range, it's DC volt, DC milliamp, AC volt, bus, and ohm meter. So next one is our range selector or range selector knob. This part is also known as a selector switch. This range selector knob allows you to adjust the setting of the multitester. So to change what the multitester is measuring, either the voltage, current, or the resistance. And our 3 holes, which is called the ports. Yeah. The holes at the front of the multimeter are also known as the port. So you need to plug your test probes into appropriate ports to allow you the multimeter to measure the parameter that you are interested. Ang last natin is the test probes. Yeah. So the positive and negative probes. A test probe or a test lead is an instrument used to connect a multimeter to a device under test, which is known as test probes. So ito ang nagtetest ng mga components. So before we start to calibrate, let's insert these 2 probes into positive port and negative probe into common or negative port. Yan. In calibrating the needle or the pointer, only need to do is to adjust this dial or infinity knob. So for example, our needle is not pointed at 0 or infinity. We need to use screwdriver to correct our pointer. So either clockwise or counterclockwise, depends in the knob. So ayan. So pinit ko siya ng counterclockwise. So tumama na ulit. So nasa 0 and infinity na yung kanyang needle. So in ohm meter range, so select natin yung range selector in the ohm meter range. Yan, multiplier 1. So let's check if this analog multimeter have deflection in the measuring of resistance. So let's touch these two probes to determine if have deflection. So no movement or wala siyang lampalo yung ating needle, so it means na okay pa naman. So kahit medyo luma-luma na yung ating multi-tester. So to check our needle or pointer in the ohmmeter, we need to short these two probes to see if the pointer is correct or pointing in the 0 ohm. So let's try. So let's first try in the multiplier 1. So pagpikitan natin to, yan. So lagpas siya, so labis. Using our 0 ohm adjuster, we can adjust the needle or pointer to correct our needle. So let's adjust a little bit. Okay. So yan, nakatama na siya. So yan. So we see that needle is correct and pointed in 0 ohm scale. So let's try in multiplier 100. So every time that we select the multiplier or we will choose other multiplier, we need to check or i-correct our needle or pointer. If nakaturo siya sa 0 ohm, so mas okay, pero let's test. So in the 100 multiplier, let's check if the pointer is in the 0. So yan, katulad nito, wala siya sa 0, so need uli natin i-adjust. Yun, tama na. So kada lipat natin ng multiplier, kailangan nating i-check or i-correct ang ating needle or pointer. So sa ganitong paraan, mabibigyan tayo ng accurate na rate or reading ng isang component. So yan ang important ng ating pagtetest at pagkakalibrate ng isang needle. So good day everyone, good morning ma'am. Today let's move on to our part 2, which is the testing of resistor components. So before we start, let's check our analog multi-tester. So let's place our range selector in ×1 and check, and let's check if have a deflection. So it's okay. So let's try this resistor. Let's try to testing this resistor. So okay, this one. So this one have a green, brown, and gold. So in our table, we have a value of 5, and the second band is brown, which is 1, and the multiplier is brown, which is 10, and have a tolerance of positive and negative 5%. So the value of this resistor is 510 and have it minimum resistance of 484.5 ohms and have maximum of 535.5 ohms. So let's check in our analog multitester. So let's try in 10K if meron tayong makuhang reading. So let's check. Okay, so no reading. Let's try in 1K. Check. Okay, so the needle is pointed at 0.4 or between in 0.4 or 0.6. So pwede siya makuha of 0.5 times 1K is equals to 500, but we need more clear reading. So let's try in 100 times 100. So let's check. So in times 100 we got the 5. So 5 times 100 is equals to 500 ohms. So let's try in 10 if we got the 500 also. So let's check. Okay, so in times 10 the needle is pointed at 50. Pointed at 50, ayusin lang natin. So pointed siya ng 50. So we got 500 also, or 4. Let's try in times 1. Let's check. Okay, so in times 1 the needle pointed at 500. So it means the value of our resistor is 500 ohms. So our resistor is function because we get the reading within 500 ohms. So let's try another one. So this resistor, the resistor color coding of this is red, brown, and gold. So in our table, so red is 2 and the second band is 2 also, and the multiplier is brown, which is 10. So the total of this resistor is 220 ohms with positive and negative 5% tolerance, and the minimum of this resistance is 209 ohms and the maximum is 231 ohms. So let's try in our analog multitester. So let's try in the 10K or 10,000. So adjustment checking. So let's try. So okay, no reading. So let's try in 1K. Take our needle into 0 ohm. Let's try. So the needle is pointed at 0.2 in 1K. So 0.2 times 1K is equals to 200 ohms. So let's try in 100. In 100, let's check. Okay, So nasa 2. So 2 times 100 is equals to 200 ohms. So times 10. Let's try. So let's check. Okay, so 2 times in times 10, we got the number. Yun, nasa 221 kasi nasa pagitan siya ng 20 and 22. Okay, so nasa 210. So let's try in 1. So let's try in 1. So okay, so in times 1 we got 200. So 200 times 1 is equals to 200 ohms. So these resistors are still working. So sila pare-parehas ang value, so nagbo-work pa sila. So pwede pa, so nagpa-function pa sila. So ayan po ang ating pagre-read at pagte-test ng ating resistor via analog multitester. Let's proceed in our next part, which is testing a capacitor components. So first thing to do in checking our capacitor is to check if have any issue or damage. So this is our electrolytic capacitor. So this is 1 microfarad with 50 volt. This is 470 microfarad with 25 volt. This one is 1000 microfarad with 16 volt. So I think these capacitors are good, and I think it have no issue or damage. So I think this is good. So far, so our first to do in checking of capacitor is always known the polarity. So this is the negative terminal of capacitor, and this is the positive side of capacitor. So ang negative niya is always the stripe like this. So okay, so in testing capacitor, the things we need to do is our positive probe is always in negative terminal of capacitor, and our negative probe is always at positive terminal of capacitor. So let's start to test these components. So let's start in this one with 1 microfarad and 50 volts. So our range that we need is 10K in the 1 microfarad. So let's check if our needle is pointed at 0 ohm. So it's good. So before we start, let's discharge first. Okay, so discharge muna natin ang ating capacitor. Okay, so tingnan natin, check natin yung ating needle pointed at 0. So positive probe into negative terminal, and negative probe into positive terminal of capacitor. So let's start. So that we can see the needle is moving and back into infinity. So let's try again. Discharge. Up. Okay. So this one is good. This one is good, and so far working in our testing. So let's try this one. Our 470 microfarad with 25 volt. So 470, we need to replace our range into 10 times 10. So let's check. Oh, so we need to adjust. Okay. So again, discharge first. And positive to negative. Okay. So pumapalo po yung ating needle. Again, discharge and test. Okay, so pumapalo pa, same siya nung first one. So let's try this 1000 microfarad with 16 volt. So first we can change our multiplier into times 1. So let's check. Okay, we need to adjust. So we need to discharge first. Discharge. Okay, so check again our ohmmeter. Okay, so let's check. Negative, positive to negative terminal, negative probe to positive terminal. So okay, so yun, pumapalo again. Yun, bumabalik siya agad. So those capacitor na tinest natin is nagpa-function pa at natetest pa natin. So pwede pa natin itong gamitin or i-replace kapag meron tayong nasirang capacitor. In testing and reading our capacitor, the things that we need always to remember is, first is always be safe and do not hold na basta-basta ng ating capacitor, because minsan nag-i-store pa rin sila ng energy. So the next one is, when we test the capacitor, always discharge before we test, and our positive probe is always in negative terminal, and our negative probe is always at positive terminal of a capacitor. So that's the thing that we need to remember while in checking or testing our capacitor components. So that is all for our topic in testing of capacitor. Good morning everyone. Good morning ma'am. Today we proceed in our next topic, which is testing of our transformer components. So So today I have a transformer. So our transformer is composed of 2 or more coil of wire. So to check our transformer, we need to see it have a continuity or resistance. So it means if we have measured it have a continuity and resistance, it means that our transformer is still working. So the transformer that I have is step down transformer, which is the primary coil or input is have 220 to 110 volts, and the second coil or our output is 12 volts. So it is called also a center tap transformer. So let's test our transformer. So first thing to do or test in our transformer is let's select our range knob into multiplier 10, because in primary coil it have a high resistance. So let's test our primary first. So okay, let's calibrate muna. So mahalaga palagi magka-calibrate ng ating 0 ohm sa needle. Okay, calibrated na. So let's check. So ayan. So we can see that our needle is moving and measuring the resistance of the primary. So medyo mataas. Subukan natin yung 10. Okay, mababa. So okay pa naman yung ating primary coil. So let's check our secondary coil. So let's select our range knob into times 1, because the secondary have a small amount of coil wire. So let's see if have a continuity and resistance. So secondary, let's check our range needle. Okay, calibrated well. So let's check. So 012. Okay, nasa 0. Let's try another. Yun, 0. Okay. So I think na our transformer is shorted, because we measured that it's pointed at 0 ohm. So dapat kahit may kakaunti lamang na ma-measure, kahit nasa 0.6 is okay, pero tumuturo siya into 0 ohm. So it means na maaring shorted na itong ating secondary coil. We can also test our transformer about in his shorted body. So titingnan natin kung may shorted ang kanyang body, which is this. So if our needle is moving and have measured resistance, it's mean that our transformer have shorted in the body. So let's try. times 1. So again, our transformer have no polarity, so like our resistor. So let's check. Okay, another one. Okay, and the last one. Okay, so no, wala pa naman siyang shorted sa kanyang body. So let's try in primary. So 10, calibrate. Same lang, tetest lang natin yung mga pin niya kung may shorted sa body. So okay, okay, so okay, so wala pa naman siyang shorted sa kanyang body. So our transformer is tested, so we see that our primary is working and the secondary is shorted. It means that our transformer is not function well. So that's all about in testing our transformer. So today, let's move on our next topic, which is testing of diode. So our diode is a component that allow an electric current pass in one direction. So our diode is have a polarity, which is the thin gray stripe is called the cathode, which is the black part is our anode. So if we test or read our diode, it is like in capacitor. So our positive probe is tapped in the negative terminal of diode, and our negative probe is placed at anode terminal of diode. So we need to correct our connection between our diode and in our probe. So our positive probe is in the cathode terminal because the positive probe is connected in the negative supply, while our common probe is connected in our positive supply. So we need to tap in the anode terminal of the diode. So before we start, let's select our range into times 1 in ohm range. So let's calibrate, tip correct. Okay, so let's try our diode. So let's test. Okay, so remember, positive probe into cathode and negative probe into anode. So here, so okay, mapalo sila. Let's try the second one. Okay, and that one, and the next one. Okay, so we can determine also if our diode is still working if we do the reverse bias. So i-reverse naman natin yung connect ng ating probe. So positive to anode and negative to cathode. So let's try. Okay, so yan, connect na siya. So if needle is pointer in, if the needle is maintained in infinity, our diode is still functioning. So okay, tama lang natin. So ayan, subukan ulit natin. Reverse, positive to anode, negative to cathode. So ayan, so no movement of our needle. So let's try another one. Okay, and this one. Okay, and the last one, subukan natin. So okay, so we see that our diode is still functioning because based on our testing, nagre-read tayo ng value if we do the correct connection of our probe into diode. And in reverse bias, it also working with no reading. So it means that our diode is still working. So this is how we can read or test our diode in analog multitester. So if we test in forward, if it is dapat meron may current na dumadaloy, while in reverse bias dapat wala siyang current na dumadaloy. So that is all about in our testing diode components.